All right, guys, Mr. Antonucci here, and we're doing volumes of solid with known cross sections. So here what we want to do is sketch the graph, set up and evaluate integral expression that represents the volume of the solid formed when the graphs of h of x and k of x form the region S. So if we look at this graph in Desmos here, it did e to the x, which is or e to the negative x, which is in blue, and y is the parabola in green. The issue here is that each cross section is going to be perpendicular to the y-axis. So if I make my slice perpendicular, I need to do this with respect to y. So the first thing before I move on anywhere is I have to write this equation in terms of y. So the first equation, y equals e to the negative x. I would do natural log of y, and natural log of y equals negative x. So x equals negative natural log of y. If we take the other equation and solve it for y, we're going to end up with x equals square root 7 minus y minus 2. So we'll go ahead and graph these in Desmos. And now what we're going to do is get the intersection points. So this one and this one. Now I'm going to do C equals the lower of the two y values, which is 0.58723, and D equals the greater of the two y values, 6.99703. And now what we can do is start answering the question. Each cross-section perpendicular to the y-axis is a square inside with a side in S. We have our perpendicular to the y-axis slice. Square is going to be like this. So it's going to be right minus left. So on the right is the parabola, which is g of y. So g of y minus f of y squared, because it's the area formula is a square. Now the volume is going to be the integral from c to d of a of y dy. Make sure you use your variables correctly. Integral from c to d of g of y minus f of y, quantity squared, dy. Make sure everything is in terms of y there. Part B, each cross-section perpendicular to the y-axis is a semicircle with diameter in S. Cross-section perpendicular to the y-axis, but this time we're putting on semicircle, so half a circle. So the area formula for a semicircle, 1/2 pi r squared. In this case, the radius is equal to the diameter divided by 2. And the reason we have to use the diameter is because that's the length that's known. That's g of y minus f of y is the diameter divided by 2. So the area function, a of y, is 1/2 pi times g of y minus f of y all over 2 squared. So the volume is going to be, well, we could factor some things out. We could factor out a pi over 8. We square the 2 and bring it out and multiply the half and factor out the pi. And it's going to be g of y minus f of y squared dy. We're going to evaluate this integral from c to d. And we could put the pi over 8 out there. G of y minus f of y dy. You get 2.168. All right, last one here. Each cross-section perpendicular to the y-axis is a rectangle with a width in S and a height that is equal to twice the y-coordinate. The width is the distance between those two, which is going to be, the width is g of y minus f of y. And they said the height is equal to twice the y-coordinate. So if you imagine as we integrate from bottom to top instead of left to right, the y-coordinate's going to go up. So the area function is going to be g of y minus f of y times y, 2y rather. So the volume function is the integral from c to d of a of y. We can pump that in right here. Integral from c to d of g of y minus f of y times 2y. Notice I put the g of y minus f of y in a set of parentheses, then multiplied it by the 2y and put that in a set of parentheses, and then times the dy on the end there. And that gives us 42.15. I've answered all the questions here. Hope that was helpful to you guys.